Every human being alive today shares more than 99.9% of the same DNA. And yet, one visible trait varies more dramatically across our species than almost anything else: skin color. Here's what most people never learn in school. That variation isn't one story. It's at least two completely separate evolutionary stories that happen to arrive at a similar-looking result, thousands of miles apart, through entirely different genes. Every early human, without exception, lived in Africa near the equator, under some of the most intense sunlight on Earth, which means every human ancestor almost certainly had darkly pigmented skin. So the real question isn't why some humans are dark-skinned, it's why anyone became anything else, and how that happened more than once. Skin color isn't decoration. It's a response to sunlight itself, specifically to ultraviolet radiation. The leading explanation for why dark skin evolved comes down to a single, easily overlooked nutrient: folate, a B vitamin critical for healthy reproduction, birth outcomes, and sperm production. Intense UV radiation breaks folate down inside the skin's blood vessels. Near the equator, unprotected skin loses folate fast enough to genuinely damage reproductive success. Melanin, the pigment responsible for skin color, acts as a natural, built-in sunscreen. More melanin means more protection for that folate, which means near the equator, darker skin carried a direct survival advantage, generation after generation. But then, early humans started migrating north, out of Africa, into regions where the sun's intensity dropped off dramatically. And that created the opposite problem entirely. Skin doesn't just lose folate in strong sun, it also uses UVB radiation to manufacture vitamin D, another nutrient essential for healthy bones and immune function. In low UV environments, heavily melanized skin blocks so much of the already scarce UVB that vitamin D production drops to dangerous levels. So the same trait that protected against harm near the equator became a liability farther from it. Researchers describe this as two opposing evolutionary pressures pulling in exactly opposite directions, depending entirely on how much UV radiation a population's environment actually provided. The result, as different human populations spread into different light environments, natural selection pulled their skin tone in different directions to match. Here's the part that surprises even people who already know the sunlight explanation. When geneticists actually looked at the genes responsible for lighter skin in different populations, they expected to find one shared genetic origin, the same mutation, inherited from a common ancestor, spreading outward. That's not what they found. Light skin in Europeans is driven mainly by specific variants in genes called SLC24A5, SLC45A2, and HERC2/OCA2. Light skin in East Asian populations comes from a largely different set of variants, including genes called OCA2 and DDB1. Different genes, different mutations. Two populations arriving at a visually similar outcome through two almost entirely separate evolutionary paths. Scientists call this convergent evolution, when similar environmental pressure produces a similar visible result without a shared genetic cause. It's the same principle that gave bats and birds both wings, despite evolving flight completely independently. So why would evolution solve the same problem twice, differently, in two different places? Because natural selection doesn't work from a blueprint. It works with whatever genetic variation happens to already exist in a population. At the moment, a new environmental pressure shows up. Two separated populations, both losing melanin under low UV pressure, simply had different raw genetic material available to work with. So selection favored different mutations that happened to produce a similar end result. Genetic dating on one of the key European variants places it emerging somewhere between 22,000 and 28,000 years ago, with clear, measurable evidence that it was actively favored by selection during that period. A striking reminder that this specific version of light skin is, in evolutionary terms, remarkably recent. This is where the science runs directly into history and directly against it. For centuries, skin color was treated as if it marked a deep, fixed dividing line between groups of people, a simple visible proxy for ancestry, and in the worst chapters of human history, a justification for hierarchy and cruelty. The genetics tell a very different story. Skin color has changed direction more than once across human history, arising through separate mutations in separate populations, at different points in time, in response to nothing more than local sunlight levels. A trait that evolved independently, more than once through different genes, simply cannot function as a reliable marker of someone's deeper ancestry. The biology doesn't support using it that way, and researchers have been explicit about that for decades. What actually connects every human population isn't skin tone. It's the underlying genetic flexibility that let very different groups solve the exact same environmental problem, more than once, using whatever tools their own genome happened to have on hand. And this adaptation didn't stop mattering once people stopped migrating on foot. Today, millions of people live somewhere their ancestors' skin was never adapted for. Populations with deep melanin who settled in low UV northern regions face measurably higher rates of vitamin D deficiency, because the same protection that once safeguarded folate near the equator now blocks too much of the limited UVB available at higher latitudes. The reverse is true as well. Populations with lighter, less melanized skin, living under intense modern sun exposure, through travel, migration, or simply changing lifestyles, face significantly higher risk of UV-related skin damage and skin cancer, because that skin evolved for a world with far less direct sunlight than they now encounter. In both directions, the same evolutionary trade-off that So the next time skin color comes up as though it's some deep, ancient marker of difference, here's what the actual evolutionary record says. It's closer to sunscreen than to ancestry. A visible surface-level adaptation to how much sun a population's environment happened to provide. Rewritten independently more than once in different places, using different genetic tools each time. It's one of the clearest examples we have of the same evolutionary pressure acting on the same species, twice in two different corners of the planet, and arriving, remarkably, at nearly the same answer. Given that light skin alone evolved independently at least twice, what does that tell you about how we've historically used skin color to divide people? Tell me in the comments.